now we will see that how we will proceed for the structure analysis and design. Okay, so inside the structure analysis and design part, we will deliver you some of the project. Okay, today in this session we will deliver you some of the project. Based on that, you can get the idea that how is the training follow in their step by step. Okay, so first we will you will see here that just take an example of model analysis. Okay, so the model analysis, when we are going to do the model analysis, it means we are checking the frequency and time period of the structure. Okay, based on their vibration. Okay, the how the vibration are going to affect our structure. So we have the listed topic. So inside that we have this model analysis, loading, diaphragm, static linear, non-linear analysis, dynamic linear, non-linear, p delta, buckling, creep shrinkage, auto construction sequence analysis, control of deflection, damper, interpreting analysis, detailing. Okay, the behavior of the building, lateral forces resting structure type, the building response to the load action, and we have the advanced part. This is the advanced part. Okay, so now let's see that uh, the immense capability of this training, that how it's going to change your career and ability in the structure field. So here we have ETAB. So ETAB is known to all of the structure engineer. It's very famous software. This is not only in this training, we will also include SAP 2000. Okay, so the SAP 2000 is also an part of this training. Got it? So now let's see that this we have the type of structure that we can analyze in this one. So here you are seeing that we have multi-story residential structure, right? The project we will take inside that one. Okay, multi-story residential structure, multi-story commercial complex, multi-story parking garage. Okay, the we have tall building and complex shear wall, the circular curved building, flat slab building, building having buffalo slab steel building. Okay, they are the analysis type. These are the capability. Okay, inside that, most of the part like that relates with the structure, it will cover inside that one. Okay, this is the like capability of the software. Okay, that what type of analysis this can perform by the software. The code we are going to use, that is IS code, British Standard Code, the BS code, AISC, UBC, ASC, FEMA. This all code we will use. Okay. Next we will see that how the structure design process are taken. Okay. So first of all, like whenever we start, so we start with some of the architect input. Okay, so after architect input, we will go for the modeling. After modeling, we will go for the analysis. And when we enter into the analysis, so analysis, it can be executed based on three parts. Like we have theory class, we have concept class, okay, or plus code, and we have software. So these are the three steps that involve in any kind of analysis. So it's not only the software; it will take many things inside that. Okay, now let's see that how it's governing the structure process. So first we have the this type of a structure we have, right? That how we are going to execute this one. So modeling the structure. So here, like we have, first of all, just take an example of model analysis. So the model analysis is the checking their structure response, okay, for their pre-vibration mode. Okay, that we have some of the technical consideration for that one. Okay, that the time period of the structure is you have to check for like t equal to 2 pi root under m upon g, right, Kareem? M upon k.
M by K,
Hello.
sir.
Yes, this is m by k. So this is the formula to check the like time period of the structure. Okay. So inside this time period, if we are checking that one, so first of all, let's see. We will take one project. Okay, to explain you this all the process. Okay, that how the this process are governed. Got it? So now let's see. We have this. Take the example of model analysis. After modal analysis, we will go for the lateral load dynamic action of the earthquake. That is the earthquake analysis, the wind analysis, the diaphragm concept. These are the analysis based on the seismic criteria. Okay, linear static analysis, linear dynamic analysis. The linear dynamic analysis, inside that we are going to do the that static method, okay, or the response spectrum method. But we have linear dynamic analysis, that is RSM method. We have time history analysis. Okay, we have the pushover analysis. We have P delta analysis. We have the buckling analysis, creep shrinkage, construction sequence analysis. It means after 40 year or 50 year, how our structure are going to show the result. Okay, the damper, how the damper are going to govern the structure. Okay, the analysis and interpreting the result, design and interpretation. Got it? The behavior of the structure, the lateral listing, the structure system. Okay, so let's see that how the project are going to execute. Okay, so now I will share you some of the one project. Okay, so here Karim, you are seeing my screen with the HIPAA structure. No, just wait.
Yes.
Now it's showing. So here we have some like G plus 10 structure. Okay, it's an live structure. Okay, and it's situated in the New Delhi area. Okay, that is in Noida. Okay, so inside this one we have almost 10-story structure. Okay, if you split from the base, it will just G plus 7, or if you count the basement, it's go for the G plus 10. Okay, their basement area we have, and total area that is covered in this project, that is 1 lakh square foot. Okay, so this is one of the huge structure. So how this live project are going to execute, we will see that. So first of all, you are seeing we have the architect input right now. Here you are seeing, okay, this is their layout of the structure. Next we have this, we have their column placement, right? And here we have three sections, that is A, B and C. Got it? So here you are seeing the section. We have first floor beam plan, first floor beam plan for the section A and B. Okay, now we have this, all are the architect input. Okay, so architect will give you the input command, okay, or the input to fill the structure requirement. They will also advise you to give the what you can say, that where you have to place the column. Okay, but see what will happen after this giving this project or assigned to you. First we study this structure, we will do the changes in the structure. After that, we will make some of the center line, that is called the beam center line, or the that like column placement or the arrangement of the grid. After that, we will enter into the E tab. Okay, so the E tab are like immense capability to analyze the structure. Okay, so we have some of the modeling criteria. Okay, that how the modeling are going to do. Okay, so first we will see that just see that here we have not this one. Let me show you the exact project that we are going to take here. Okay, yeah. So here we have the same structure. Karim, this structure is okay or something is missing here?
Sir, go for the options part.
Okay.
Options. Control the graphics, sir. Yes, options. Graphic mode, standard graphics. Yes, graphic mode, sir. Options, graphic mode, standard.
Okay, so these are the this is the model that we have created in this structure. Karim, so here this is the final structure that you have developed.
And basically, sir, this project is distributed in three parts. Okay, block A, block B, C. In this project, we have got a block A as well as a middle side portion with block C. Okay, so two projects embedded in this one, block A and C also. This one, sir.
Okay, so we have block A, block B, and block C. So this you are seeing, this is the block A and B. Okay. Now, in this project, you will see there we have performed all type of analysis and recommendation that we have to do. So first we have performed the analysis, that is Karim will explain you how many kind of analysis that he has performed. So Karim, can you explain that how many kind of analysis you have performed on this structure?
Sir, can I share the screen this structure block is on?
Yeah, just share your screen and explain.
Okay, sir. Please allow, sir.
Now share.
Okay, so able to see my screen, sir?
Yeah.
So basically, this projects for the block A, we have to be considered. Okay, so whatever the material section sizes, we have to be consider as per our center line plan. Okay, so our reference model just prepare, which can determine the position of members, whatever the particular position as per the requirement for the architects. Initially, we are consider. Okay, sizes we have to be considered as per judgmental idea. Our model will become complete. First of all, we have checked the model, some errors or not. Okay,
Yeah.
our models with free for errors, moving for the model analysis.
Okay.
Basically, we identify the stiffness of our structures. Our mode 1, mode 2 will become pure transitional of node. Okay, so moving for the defined part or the options, load cases. Okay, so the options available in the model, modify, showcase. So as per the number of modes we have to be considered. So we have selecting the red factor, eigen red factor, both factors we have to be taken to perform the model analysis. So we are selecting the red factor for our high-rise buildings or escalations in terms of UX, UI, UZ, RX, RY, RZ we have to be considered. Number of modes as per the judgmental idea we have to be considered. After that, when we performing the analyze, so what's analysis we have to be consider as per model analysis. So it is already analyzed. Moving for the deform shape or moving for the display part, show tables part, check our results. So model analysis as per the self weight, our results will become convenient or not. Okay, so identify the stiffness. So initially make the structure, our stiffness will become symmetrical. Otherwise, you have need to revise your model. Okay, so we can see starting the three modes, mode 1, mode 2, mode 3. The rotation values in terms of RZ will become less than 10%. Okay, it means these are the less than 10%, which is pure transitional. Third
Okay.
mode will
Fine.
become torsion.
Okay.
It
So
means our analysis will become okay, sir. First
yeah,
analysis is
fine. So this is the first analysis that we have to perform in the structure. Okay. Inside that,
hmm.
see, we have considered their self weight. After that, like what kind of analysis, Karim, will you explain?
Sir.
What kind of next analysis you will perform?
Okay, sir. Basically, this structure initially we have
Explain
to be
all type of analysis. Okay.
okay. So first of all, we are discussing about the model analysis as per the self weight, no external load. We are consider self weight as a freehand vibration. Structure gives the response on the behalf of freehand condition. We can identify the particular time period to complete a particular oscillation. So first analysis will become important. Model analysis will become efficient moving for the external loads, which is also efficient for dynamic analysis, which is also efficient for torque irregularity. Okay,
Yeah.
so first analysis when we complete, we are moving for external loads as of external force. So what is the behavior or give the response of the structures when we applying the external forces? Okay, so
Yes.
force we
Yes.
are distributed in two parts, gravity and lateral. Okay,
Lateral.
so gravity loads we have need to calculate the which force we are take. Force also important part. If we using the Indian standards, we are calculating the gravity loads like the frame
Yes.
loads, area loads, point load, whatever, which is depends upon the finishing of the material as per requirement for the architects. Okay, so
Yes.
we are calculating the all frame loads. Okay, if you want to see our loads, go for the display. Load assigns the frame part. Okay, so loads we are applying the super dad load or apply. So, sir, you can see these are all the frame loads we have applied to calculate as per our requirement. Whatever the masonry loads or brick
Okay. Fine.
masonry, these are the frame loads we are calculate or
Sure.
apply. Similarly, we have need to
Okay.
calculate the
So,
area loads also.
yes, yes. So the thing is, see, just wait. Whenever you are designing or analyzing any structure, first of all, you have to take the load consideration. That you are taking the forces in terms of their gravity load and the lateral load. Lateral load in the form of seismic load, the wind load. Okay. So first of all, like whenever our classes are taken place, it has been taken in place. So we have not only the software part, we have lots of things that associate with this. Like just take an example of model analysis that we have discussed. So now if you see that it's how it's related with the dynamics. Okay. So whenever we are going for the this presentation or these classes, so first we will learn about the dynamics of the structure. Okay, like how the dynamics of the structure is governing. Karim, please stop sharing your screen. So in first, the Karim has explained you the model analysis. Let's take an example how the classes is taken. So first of all, we will learn about the dynamics of the structure. What is single degree of freedom? The multiple degree of freedom. Okay, the vibration, the 1 degree of freedom. Okay, the undamped vibration. That is first. The second one we have the damped vibration. Okay, then we have the these are the earthquake response. Okay, the envelope, the exponential envelope of the graph. Okay, the mode. So basically, we are seeing this one the mode, like how these are governing our structure in free mode vibration. So let's just take an example, like if any earthquake is happen, okay, in their free mode vibration, you can see our structure are behaving like this. Through this video, you are seeing the one frequency is applied, okay, and the structure now is starting vibrate. But let's see that if you are increasing the height of the structure in single degree of freedom, now you will see if you increase the frequency of the structure, okay, then the high rise structure are going to affect less affected. Okay, like see here in the low frequency, this third option you can see this one, this one is vibrating more according to this and accordingly this. Okay, so this have more vibration now. But if the frequency, okay, the frequency is increasing, now you can see after some limit, what happens? It will reverse. Reverse means the highest vibration it will give by this one and this one. Just see, okay, got it. Now again the frequency are increasing, and in the last, if you see when the frequency are so high, then your high rise structure is stable, okay, and the low rise structure is get affected. So that's why in the model analysis we are checking the structure response, okay, the vibration, okay, and where we have to apply the exact criteria in the structure, so we can make the structure more stable. Got it. Now if you see the vibration mode of the tall structure, right now, okay, let's see this one we have. Okay, so inside that you are seeing that whenever the lateral forces are going to take place, these are the pre-mode vibration. Okay, of the building. That is mode one, mode two, and mode three. Got it? Got it, Karim? So now Karim will tell you the next part of the that this software. Okay. Hello, Karim. Kindly explain again.
Yes. Okay, sir. Okay, so sir, finally, when we completing the model analysis, okay, so we are calculating the external force like the gravity loads, frame loads, area loads. We are calculate as per our materials finishing requirement for the architecture. Okay, so when we moving for defined part, we have defined the pattern, which patterns we have to be considered. So you can see that one which represent the self-weight on the behalf of we are performing the model analysis. Okay, live loads, super diet loads, these are the part for the gravity loads. We have to be taken IS 875 part 2 for calculating the super diet load. Live load we have not calculated, just take as per occupancy. Code already provide, we have to be extract from the code or apply. Okay, so these are the gravity loads we are applying. After that, we are moving for the lateral loads also. Okay, like the seismic analysis or wind analysis. Okay, so seismic analysis, so basically we are moving for external loads. So analysis at the first one, gravity analysis. So the gravity analysis we have to be considered depends upon the gravity load cases. Sorry, gravity load pattern. In that part, dead load, super dead load, live load, finishing load, snow load, whatever. These are the loads will become acting as per the gravity point of view. If you want to see our deflection, so deform shape, or selecting the particular case. I want to see the deflection for the particular dead. Okay, so we are selecting apply. Okay, so in that part we can see the structures which can give the deformed shape as per the gravity, it takes some time taken or give its deformed shape. So finally, we can see that when we apply the gravity analysis, structure gives the response as per the
Sure.
gravity. You can see the
Okay.
structure will become deflect as per the gravity.
Yeah.
In
Now we
that
will
part, we
check
can
for
see the
the, yes.
deflection as.
Yeah.
Hmm,
So now we will check
hmm.
for the lateral load. Okay. Kindly show for the lateral load, that is linear dynamic
Okay.
analysis.
After covering the gravity analysis, moving for the lateral load part. So lateral load part basically the seismic part, the wind part. So seismic basically divided a lots of examples, static and dynamic. Static also linear, non-linear, dynamic also linear, non-linear. First of all, we are moving for static part, sir. Okay. So static part we are moving, selecting the codes. So these are all the parameters we have to be take as per our code. What is your seismic zone? Calculate the time period, soil type. Okay, so these all the parameters we have to be taken as per code. EQX, EQY, we have to be defined. Okay, after that, we are show for deform shape, also the deflection along the X direction, Y direction, or we can check our results, display story response plots. So gravity analysis or lateral load, both are included in that part. We have to be got it maximum historic displacement, or when we see the displacement for the static analysis. Sir. Suppose we have to see the static analysis. Okay, so you can see
Yeah.
these are the results. So base shear values which can provide 1845.96. This one. Okay, these are the
Sure.
forces required to balance unvertical forces. So it is the analysis for linear static.
Okay.
Okay,
Fine.
unbalanced vertical
So
forces
so
which can
here you
control
are,
this one. Sir.
yeah, here you are seeing that the forces are applying in the x direction and the y direction, that is the
Hmm.
seismic force, and based on that you will see the story response. Can you kindly show the story response, like
Yes.
how the
Okay.
deflection is, uh, like the
Hmm, hmm,
lateral
hmm,
deflection, how you
hmm.
will see the lateral
Okay.
deflection. So let's see.
When we performing the seismic analysis, so as per code we have need to check the deflection. Okay, so as per the code that the deflection will become allowable, we have moved for maximum story displacement. Okay, so we are selecting the case for EQX, also along the X direction. Sorry, we are changing the case, selecting
Yeah.
the case for along X direction. Okay, so as per the code says that the allowable values which will become h upon 250. What's your height? Divide
H
by
upon
250. 250.
250. So if your
Okay.
height of the building is 250, and the 250 you have to divide, then you have to give maximum storage displacement, that is 1 meter, right, Karim?
Okay. Sir, if we identify that in the height, you can see at the bottom portion, that will
Yeah.
become 31.62. Okay.
Okay. Okay.
So when we calculating this one, so we are calculate with the help of this one. So 31.62 multiply by 1000 to changing in or 250 will become, okay, it means 126.4 F. Approx
Okay.
127 it is allowable. Okay,
Okay.
so again move for check the displacement. So this one values we have to be got it, EQX 51 sir. It is allowable. It means
Okay.
our
So
structure
it means
deflection will become
our
pass.
structure is pass.
Hmm,
Okay.
hmm.
So here we have checked for the which type of analysis.
These are the linear static analysis for
Okay. This is
performing the displacement
linear
check for
static
seismic.
analysis. Okay, so these are some of the examples that we are taking here and explaining you that why it's important to study the software, their codal provision, and this all kind of things. Okay, now I will go to the some of the like after see. Karim, after analysis, we have to do the design, okay, and we have to optimize the structure, right? So
Sir, when
yes,
we performing the seismic analysis, we are moving for dynamic analysis. Okay, see the dynamic behavior, check
okay.
the story stiffness, frequency check, mass participation, a lots of
Okay,
checks, sir.
just wait,
Okay,
just wait. Open,
so
open this fourth envelope. That is case combo.
case combo basically,
Here,
sir.
here, below option. Kindly open that one. Yes, click on that. Yes, yes, yes. Just wait, wait. So if you see that how many kind of load has applied, can you scroll up? Okay, so here you are seeing these are the, just go up, these are the list of forces that we have applied on this structure, that live load, dead load. There are lots of type of things that we have applied here, and based on that we will check our result. So here if you see, this is not only the software part. We have to calculate each and everything based on our code and concept. Then we have to apply in the software, and again we have to interpret the result. Okay, so now after taking this consideration, okay, we have lots of type of analysis. Can you show the load case for the RSM method here?
Okay, sir. So moving for the dynamic analysis, we have to define the cases. Define, sir. First of all, moving for the dynamic part, sir, we have need to
Okay,
define the function. Function.
okay, function.
It is
Here
the
you are seeing,
important
see,
part.
what is the difference between the seismic analysis? Like you are seeing the RSM method. Can kindly open that one, Karim? So the
Response.
response spectrum method, it means see. So the yes, just wait, and go above and show the this linear XY option. The plot option, in the plot option, change to, yeah, or go back. Just go back. Cut this one. Yeah, again go here. Add new function. Yes. So now what you are seeing here, that we can apply many type of loading. Okay, how many type of loading it has? Like when we are going for the seismic analysis, it means we can apply the load in the two forms. First form that we can apply, that is with the wave form. Wave form means like it may be the sine wave. Okay, it may be the sine wave. It may be the cos wave. Generally, the earthquake forces are travel in this one. And previously we had talked about the envelope. Okay, so they are just graph. Most of their graphs, it will show you the exponential graph. It will travel like this. Okay, so we have two method for quick analysis. Like we have this RSM, and we have this what kind of analysis, Karim? That is time history method. So the time history method, we are taking data from our previous record, and here we are applying the code. We have the earthquake analysis, uh, the recommendation from the IS code also. Which IS code, Karim, applicable here?
IS 1893. We have to be using the for performing the seismic analysis, sir.
Yes, IS 4
1893. IS
18.
1893.
Okay, 1893. Okay, so this is a code
IS.
that we are going to use in this one. Okay, and we have seen, if you read the code and if you take the consideration, just let me show you that how many type of code that we can utilize. Okay, Kareem, stop sharing your screen, so I will able to share my screen. Okay. So here we have, see, here we have IS code, okay, American code, right, and the Indian code that we can utilize. Okay, so first of all, you will see that we have a high-rise building code and IS code. So inside that IS code, we have this IS 4561987. This code generally used for the that seismic analysis, right, Kareem?
Yes. Basically seismic for IS 1893.
Okay, okay. So here you can see that seismic provision that is given in the code. Okay, and based on that we can check that all the things. Okay, we have this IS part 1, part 2, and part 3. Right now you can see the code are very much useful. Okay, while doing this type of analysis, but it's not always true that we are going to use only national code. We will also use the international code. Like here you are seeing, this is the Indian code that we can utilize for the which kind of structure, that electrical transition lift. It means for the loading part we can apply this type of thing, right? Next we will see. Just wait. Here we have this code. Okay, this all the codes we have. Now we will go to the code that is called the high-rise building code. So for the high-rise we will discuss later. Now here you can see that we have the UBC code, that is Universal Building Code. So now let's open any code and let's their implementation. Okay, so the UVC code is also important, as you are not only staying in the India. Some of the people are going for the abroad going to abroad for their jobs. So there is lots of demand. Okay, so you can see this all the code. You will thoroughly, we will give you like detail of this all the code and how it's going to apply, how you have to apply this all the things. Okay, so these are the code that we can use in the structure analysis or design, right? So after completion of putting design, that superstructure design, what kind of design, Karim, we will go for? So now just I will share you. Okay, so here we have after superstructure design and analysis. See, there are lots of analysis you can see in our type of like presentation. Okay, now we will go first. We will explain you the foundation part. Later we will go for the that superstructure design of the tall structure. Okay, now here you are seeing that we have the the slab, the foundation. Okay, the foundation and the slab. It's an substructure type. So can you open the same project? Okay, that we have shown you the live project, and for that one we will show you that the slab design and analysis, and also their foundation design. Karim, kindly share your screen and explain.
Okay, sir. First of all, we have opened the foundation part, sir. Okay, sir.
Sure.
So we have shared the screen. Sir, basically, it is a substructure part for this project. The previous one we are open it. Okay, superstructure. It is the substructure part. So we are exporting the reaction forces. Okay, reaction forces when we import. After that, we have to performing the modeling for substructure part, whatever the materials for the raft, isolated or stiff property we have made, some retaining walls. Okay, after performing the modeling, the substructure part, we have need to performing the checks. Okay, so if we're moving for the display part, show deform check shape, or we have to be taking the combinations we have to be taken for the as a plastic point of view. Okay, service part or the deflection we have to identify. So it gives the maximum values for 24.68, sir. Sorry,
Okay.
basically it can showing this one minimum value is 49.18 as per the gravity point of view, this one. Or we can identify the values which will become showing if our value is greater than this 75 mm, which can showing this contour color, sir. It means not show this color at the magenta. It means all the deflection which is limited, allowable 75 mm. Okay, if our deflection values will become higher, we have need to modify the its geometry. Okay, we are controlling the deflection. These are the deflection check, or we are moving for solve pressure check to the important part. So we have need to check the solve pressure. Depends upon the SBC, sir. Whatever the SBC we have to be considered. Our SBC we have to be taken 250. Okay. So 250 basically your pressures not greater than as per our SBC. So when we performing the analysis, which can give the values 180, sir. It means our allowable values 178 lump sum 180 value, this one it is allowable values gives
Mm-hmm.
us, but our
Okay.
allowable sorry 250, but your deflect sorry solve pressure not cross. With the help of contours we can identify. Okay, after that we have need to identify the punching also, display part show punching shear design. Okay,
Mm-hmm.
so showing for the punching values we have need to go options for points, or points we are visible also. So it can punching the values, so you can see, which is mostly lump sum less than one. If your values cross the one, so you can also modify the depth also. Okay, some
Okay.
minor values acting one lump sum. Okay, basically, sir, the soil pressure or the deflection we are control by increasing the geometry, increase the area. Or if
Okay.
you want to control the punching part, so with the help of depth we have to be controlled. Depends upon the analysis results we have need to design. Okay, so moving forward, display and deform shapes or display, whatever the forces will become acting, we can identify the in terms of bending also the forces will become acting. We can also check our results. Okay, so a lot of checks we have need to consider on the behalf of we have need to design also. Okay, so these are the forcing will become acting when we identify in terms of F1 forces, the movement will become Okay. After that, when we moving for the design part, show options. The options show slab design. So on the behalf of we can need to what we call as a design. Okay. The options is
Okay.
strip based, FEM based. So FEM based we have to be considering. Otherwise, strip based method also available. How much amount of reinforcement you can consider. Okay. So top reinforcement, bottom reinforcement when we apply, which can gives the area of reinforcement, sir. Okay. So square per meter, we can use the Excel sheet also. On the behalf of we can identify how much amount of reinforcement we have to be considered, top and bottom along X or Y, or you are using this option also, which is typical reinforcing. I want to identify top rebar, bottom rebar, or how much bar size. We are using 10 bar. The spacing we have to be considered 10 or apply. So with the have to be identify, it means at a top rebar, 10 bar dia, 10 spacing will become sufficient. Okay.
Okay.
Similarly, check the bottom part also. Bottom part basically depends upon the movement, sir. How much amount of forcing will become acting on the behalf of reinforcement will become acting.
Okay.
Okay.
So
So
see,
in this way,
these
we have
are
to be
see this.
perform, analyze, and design.
Yeah. So here we have the that footing design, or the we have used the raft foundation. But not only the raft foundation, we can utilize other type of foundation also. So now you can see that with this help of this software and with the code and the technical and the theoretical, we will able to design and analyze superstructure and their substructure. After that, we have to do the detailing of the structure. Okay. So here we are going to use some of the software program. Now the detailing is very easy nowadays. You can utilize some of the software like CSI Detailer, or you can do the detailing in the that BIM software also. So here you are seeing that Karim, after this footing, we will go for the slab design. So have you any example of the slab, Karim?
So once I will open the one slab also.
Yes. So before like going with the reinforcement, here you are seeing that we will do the reinforcement detailing, right? Like in the CSI detailer. So here you are seeing that it will create, this will software will give you the automated generated of this layout of the structure reinforcement. Okay, so you don't need to do by yourself. Okay, it will automated generated, but you can like change in that PDF and that CAD file. Okay, so these are the detailing sheets that we need to provide to the client. Okay, how it's look like. Just take an example. I will show you some of the detailing sheets. Okay, so just wait. So I will show you, like, first we need to do the like column layout, their floor layout. Okay, and they are detailing. So let's see that how you can do this all the things. Let me open the file first. So now see that we have this detailing sheet. Okay, inside this detailing sheet, you can see this is a column, their floor and their shear wall detailing. Okay, so what will be the reinforcement that we have to provide in the shear wall? Okay, what, how many, like number of bar, what will be the dia of the bar? This all kind of thing we can provide to the client or for the site. Okay, so these are the detailing sheets. Not only this one, we can also provide for the, like we have the staircases. Okay, we can go for the basement staircase. All kind of reinforcement you can provide here. Okay, like we have the basement. Let me open that all the files. Okay, so here you are seeing that we have the staircase detailing, like how you have to draft the staircase, their detail sheets. Okay, so this all we can do and provide to the client, or we will take in the training part. Got it? This is the floor layout, the standard floor layout we have. You can see everywhere we have the column placement and this all kind of things. Got it? Now we will go for the slab. Okay, so Karim, can you explain the slab?
Okay, sir.
Karim, the HIPAA structure have the slab. Yes.
Yes, sir.
So
Basically,
the
these
for
are
the
the Yes,
For
we
the
are
same
select
project,
imported.
yes, we
Mm-hmm.
have for the same structure we are going to design the slab. Okay, so this we have the slab. This is the flat slab. Okay, so here not flat slab. This is the what kind of slab
So
we have.
basically the normal slab we have to be
It is
taken.
normal slab. Okay,
Okay.
okay. So this is the normal slab that we are going to design and analyze in this CSI cell. Okay, with the help of code, concept, and theory. So
Sir,
basically here we have
sir,
to check the deflection, right?
Sir, basically, we have already take the slab tab in our E tab. Okay, so
Okay,
in E tab, the slab is work as a load is transfer. Okay, so whatever the depth you have to be taken 200 mm, 250, 120. Okay, so this slab we are import in our safe. Okay, we have need to check the deflection check. Okay, so deflection check, we can check that our analysis result will become okay or not. Similarly, we can identify the reinforcement like the foundation part at the rough we have discussed previously. Okay, so
okay,
same checks we have need to apply, but in that part we have no need to punching value this one. Okay, so you have to be consider the flat slabs you have to be consider. Okay, so deflection check or other checks you have to be consider, or your results will become sufficient. You can design design the slab as per the previous the foundation
okay,
for the
got it.
rough. Okay,
So
yes, so same
here
steps
we
you have to
have
be
the
follow, sir.
deform. Yeah, deform shape we can check for the slab that how is it going to like it's allowable or not the deflection. So here you can see in this one you can check the deflection.
4.5
Got it?
mm this one
So
deflection, sir. Hmm.
yeah, definitely. So this is our all our review for the RCC structure with the like G plus 10 or G plus up to G plus 25. Okay. Now we will Karim, stop sharing your screen. Now I will show you that what part will we have to take next. Okay. So after completion, we have to do the proof checking. It's very important part of the training that how you can submit the structure report to the higher authority to get satisfied on that one. Okay. Now you can see that after completion of this basic part, we have the higher part. That what is this higher part? So this is high rise and tall structure. So the high rise and tall structure is like also an integral part of the training. And basically, if you see that what type of project that we can take in the high rise and tall structure. So let's take an example. I will show you that according to our crafted syllabus, you can check on the website also. Here we have the advanced part that is high rise and tall structure. So the high rise and tall structure, learning the high rise and tall structure, it's very important. And most of the things that you have applied in the low rise, you have to apply in the high rise with the lots of updated things. Okay, so you need to cross your limit from very basic to advanced, right? So in this one, in the high rise and tall structure, what kind of a structure we will learn? So we will able to learn the structure, what kind of geometry we will learn. So structure geometry is very important as we are moving for the like low rise to high rise. So let's see that how many kind of this structure we will use. So first we have based on the response of the structure we have moment resisting frame. Okay, so we have this beam, column, and shear wall system. Okay, that we have already designed up to G plus 25. Now we have the brace frame. Okay, brace frame we will learn. We have this type of brace frame. Okay, we have this tube system, tube and tube. Okay, so I will show you the project that relates with the tube and this type of thing. Just take an example. We have one structure that is called digrade. So digrade means we are going to like this is an example. You can take this one. Yeah, Karim, this is the not this one. We have the digrade structure. Okay, let me show you the presentation for the digrade. Okay, so that inside the digrade structure, our structure member are inclined. Okay, so inclined means we have to incline our all the structure. Okay, all the members that are lie on the outer periphery. Okay, with some angle. Okay, so here you can see just wait that Yeah. So if you see, this is the research paper that we have published for our this structure system. Here you are seeing we have changed their element, okay, the structure element to the cross. Previously we are using this straight member. Now we have changed to the cross. This is the advanced part. Inside that we will able to do the analysis of this type of structure, okay, with our national and international code, right, Karim? So here if
Yes.
we change the shape of the structure, their structure response are going to change. Okay, we have done some of the analysis. Okay, here you are seeing that how many kind of analysis we have performed. So almost all type of analysis we have taken here. Okay, I will also show you in the object project that how it's look like and their utilization. Okay, like if you see, we have compared two structure, that is one with the that conventional and one with the digrade, and what will be their outcome. Okay, so here you are seeing the maximum story displacement, okay, for the digrade and the conventional. So every time you will find the digrade is better performance. Okay, Karim, kindly just wait. I will show you the exact content for that one. So if you see that this we have some of the like story response. If we are checking for the that model analysis, we are checking for the story response, how the structured deflection are maximum story displacement. So you can see these are the that consideration we have to check in the high rise and tall structure. Got it? We have like here you are seeing that the model analysis are taken place. Okay, inside this model analysis, you can see that all the mode of the structure that are like in three mode, like first mode, second mode, and third mode, how the structure is responsive. Got it? So this is our like outcome for the high rise and tall structure. Got it? So this we are just explaining you one structure. Okay, we have other type of structure. Like we have this outrigger, we have this tube and tube. Okay, so I will show you all type of structure. Based on that, right? We can check all the things. Right, Karim?
Yes.
Okay. So after this diagram structure, what we will see, just we will extract some of the result from here. We will publish our research paper. Okay. Now the things is that relate with the high rise and tall structure. So high rise and tall structure are very much different as compared to our low rise structure. So we have to focus on the some of the seismic provision. We have to focus on the wind also. Okay, so that are an integral part of this training, right? Just take an example. We have to like how many kind of project that we will able to deliver you. So Karim, have you opened the G+52 tower?
For the foundational part, sir.
Okay, just wait. I'm opening one structure that is G+52. So inside that, we will see that. Okay, so inside the high rise and tall structure, we will focus on our gravity, wind, this all kind of things. Okay, so we will able to master our structure with their like from very basic, from zero level to most advanced level. Okay, so this is our part of the training, and inside that we will take this all the things. Just wait. So here we have one tower structure. So here I am telling you one example that is G+52 tower structure. Inside that, you will see that what kind of new consideration we have to take. So see, whenever we are going for the high rise and tall structure, we have different structure forms. Like here you are seeing that we have the podium level also. Podium level means the car parking, right, Karim? We can use this one with the like for the parking purpose. Okay. So for this one, we have different approach to design and analyze high rise and tall structure. We have some of the like non-linearity function. First, we will do the linear. After that, we have non-linear modeling of the structure. Right. There we will learn the pushover analysis. Right. All kind of analysis we will perform in the high rise and tall structure, and with their other other system also, like not only this tube and tube, we have other type of structure system also. Let's see, I will show you some of the like I will give you the case study. See, this all the things we have published in our training program, okay, inside out. So you can see that we have given this type of framing, what kind of code that we will use, okay, what will be their foundation type, their floor plan, okay, their concrete gate, rebar, design code, okay, their beam schedule. This all we have feed into the software to get the result. Okay, so here you are seeing the maximum story displacement. Okay, that it takes time, that's why we have make this report. We have maximum story drift. Okay, we have this for the resultant displacement we have. Okay, so this all are the, and we have this floor plan. Okay, for the deflection check, this all kind of things we will perform in that. Okay, so now you can see the compressibility of the training. When we enter into the advanced part, there are lots of things that we will take from very basic. Like see, there is one like example. There is one topic that is called PBD. PBD means performance based design. So see, the PBD is also an part of the training. So inside that, the pushover analysis or the PBD analysis, we will able to just see. Here we have this. We have the pushover analysis, the non-linear part of the analysis, how the pushover are going to take purpose of the pushover. Okay, the PVD design base, the performance objective. Okay, the performance spectra, performance definition. This all are the example. Okay, example or the topic that we will cover. That is the tema, the code we will use, their maximum story displacement with core wall, without core wall. Okay, the hinge formation in the step of pushover analysis. Right. After that, after taking this consideration, not only with the this topic, we have other topic. Like see, we have wind tunnel test. Okay, so how the wind tunnel tests are going to be take place. So here you are seeing that we have different presentation for that. Okay, wind simulation, the wind tunnel testing. These are the wind tunnel test equipment. But we have the software program to analyze that one. We can easily identify that how the forces are attracting and how we are going to do that part of the training. Okay, so these are some of the like example and the technical presentation. Not only this tube and tube, we have the breast tube, we have the outrigger press system. Okay, so now I will show you one project that are very great. Okay, that will taken inside that one. This is walls tower and it's like G plus 80 story. Inside that we will also do the case study of the structure. Okay, we will learn in depth about this all the things, right? So this is the beauty of this training. If you search that where you can find this all the training, so I will honestly tell you that this training might you will not find on internet or any kind of platform. Okay, like see, we have this pushover analysis. For the pushover analysis or non-linearity behavior, we have research and development inside out. Everything we will learn. We will do the tactile detailing of the structure. We will check the performance level. Okay, the beam model. Okay, strengthening, reformation parameter, structure components, ductility. This all are the hysteresis loop. This is very important part of the training. The how you can identify that how our structure are regaining their shape. Okay. So after completion of this, all the research and development, this basic to advanced level, we will able to summarize and we will provide the project report, okay, to the higher authority to check that thing. Got it? So this is about our structure analysis, design, detailing of superstructure, substructure. Right, Karim?
Yes, sir.
Okay. So after this, just take an example like one important part that is left here, that is called the wind simulation. Okay, so wind simulation is also an we have to perform the wind simulation, but where? Okay, so the wind simulation, like we can perform in some of the software like RWind. Okay, so inside that we will check the real behavior of the structure, how this wind are going to affect our structure, what will be the response of that structure inside that wind, like when we have the wind forces, like if you are living in the some of the like country, they have the high load of the wind, like when you are designing the skyscraper, then mostly it will utilize. Okay, so the wind analysis is also a very advanced part of this training, and we will take the consideration of that one also. Right. Now, after completion of this module, we have one module that we you can say that is called the BIM. Okay, the BIM. What is this BIM and this all things? Let me explain you. The BIM is some kind of implementation, right? Just wait. So now we will jump to the BIM, that is Building Information Modeling or Management. So what is this BIM? So whenever we are seeing the word BIM, we generally see that BIM is the modeling of the structure, but not. BIM is not only the modeling of the structure. Let me show you that what is this BIM. Now we will jump to the third part of the training, fourth part of the training, that is called the BIM. Okay, the BIM, implementation of BIM, Building Information Modeling or Management. So what is this BIM? Let's understand with our simple slide. Okay, here you are seeing that we have uh, BIM dimension. So first thing that we have the modeling. So inside model we will do the architect modeling, structure modeling, and MEP modeling. So this is the layout of the this training, that we have the 3D geometry, the fourth dimension is the time, fifth dimension is the cost. We will do up to the cost also, and we will exceed our limit if possible up to the 60. Okay, that is the that calls the sustainability. Okay, sustainability and facility management, right? So the 3D model is the XYZ, everything we have height, that length, breadth, and height, that is called the BIM, and this is the geometry, right? We have the 2D drawing. From there, we have converted up to the 3D model, right? After that, we have this time, that how the time is going to taken in the inside this inside that one, inside this program. Okay, so the time, first we understand about the BIM modeling. So BIM modeling have three parts, that is the architect part, structure part, and MEP part. Okay, like see, we when we are doing the MEP, that structure modeling, inside, not structure, which we will start from the architect modeling. So here you can see that this is the interface of the software. Here one model is going under development. Okay, so here you can see that we have created this type of model. Okay, for the architect layout. Got it? After getting this architect layout, that is the building information modeling part, we will get into the that structure modeling. Okay, so the structure modeling, it means we will create our structure model. Okay, so the what is this structure model? Just let's understand. So in the structure model, we will implement what kind of thing, that the same thing that we have implemented in the software like ETAB, SAP, and this all kind of. Okay, so this is an example of this like structure modeling, right? After structure modeling, we will go for the BIM modeling, that MEP modeling. Okay, so the MEP modeling is also an part of this training. So inside that, we will able to learn the mechanical, electrical, and MEP, that called the mechanical, electrical and plumbing. Okay, so here you can see that one pipe system or duct system is going under development. Okay, so we will implement that one. Got it. After that, the BIM is considered for their next part that you can see here. Just take an example. Okay, let me show you. Yeah. So here we have BIM for the that AEC industry, that is architect, structure and contractor. Right, Karim? So
Yes.
here you are seeing that we have this. First we have the 3D model. So after making the 3D model, we will go for the 4D, that is the time. Okay, so after time we will go for the cost, that how much cost is required for the structure, right? So we will create the schedule for that one. Okay, the costing and the sustainability, that how this solar analysis, the wind analysis and this all kind of thing will take place inside that one. Next we have the BIM facility management, that is the 8D. This all are the BIM, their collaboration. Okay, and how many kind of software that we can utilize inside that, that is Autodesk, Tekla. Okay, these all are the software collaboration, and we can easily collaborate with structure to BIM. Okay, we have that IFSC file or other plugins that we can utilize there. Got it. So after this one, after completion of this BIM part, we can also make the schedule. Okay, schedule or the enforcement detailing in the BIM. Okay, like see, if we have to do the foundation detailing inside this software, that how we can do the this foundation detailing. Right now here you are seeing that one foundation detailing are under process. Okay, so these are the detailing sheet that we can directly create, and bar bending schedule, this all kind of thing we can arrange in this software, right? Now you will see that after completion of this all module, we have some of the infrastructure projects, like how many kind of projects we will take in the infrastructure. So inside the infrastructure project, we will take some of the, like I will show you that water tank, this kind of structure we will take inside that. Okay, so let's see what is uh, this type of thing. Okay, so which type of structure we will take in the inside that. So we have this all the project that we will take inside that one. Got it. So how many kind of project we have, Karim? Here we have underground water tank, retaining wall, overhead dome structure, truss. These all are the part of the training, and we will do in the SAP 2000 software package with the national and international code. Karim, kindly show the screen with the SAP and the infrastructure project.
Okay, sir. First of all, we are moving for the dome structure, sir. Okay. So we have shared the screen, sir. So, sir, see this screen, sir. This dome structure.
Yes.
Hello. Sir, basically, we are performing the modeling for our dome and the shell part. So dome is supporting below some members like the columns or beams. These are the wireframing, okay,
Yes.
which can support the dome. But the top portion at the dome part, when we see this top portion, okay, so this dome part we are performing if you interested in someone steel plates or using the RCC, okay, so depend upon your requirements you have to be considered. Okay, so then we performing the modeling or as a wireframing part which can support in this one. So when we performing the design, so we can see the how much amount of deflection values like the safe part. Okay, so see this one, or when we scroll down like this. Okay, so particular shells which represents the dome. Okay, we are splitting someone as a shell part. If we are interesting as a steel, so steel plates also using, or if I interested in the RTC, so RTC bars we are providing. So depend upon the requirement, which shapes, sorry, basically depend upon the type of material, which materials you have to be considered. Okay, so
Mhm.
mostly using the RTC domes, it is a wall part. When we performing the analyze, again see for what we call as a deformed shape. So in that part we are moving what we call as a deformed shape, this one. So particular casing we are interesting, suppose I want to check the deflection check for a particular case. So we can see the deflection values which will become showing or the contours will become along the UZ as per the gravity point of view. So we can identify the deflection values will become how much values we have to be got it. Like the safe, okay, sir. So we have need to identify the deflection. Okay, how much structure will become deformed it, or we have need to modify the depth, whatever the shells we have to be
Okay, so
considered.
this is one type
Okay.
of example. Okay, that is the dome structure. We can design the water tank also. Karim, show the water tank.
Okay, sir. Basically, sir, in these models, you can see these are the portions for the wireframing, which
Okay,
represents the member which support, basically performing the modeling for the storage dam. This storage part. This storage dam may be ground level, maybe underground level, or maybe overhead. Okay, so these are the elevated, these are support. So this dome, basically some water pressure required, some soil pressure. So in that part, we have need to assign some pressure, okay, or checks the structure deflection, okay. But when we performing the analysis, these members, lateral loads, wind load, like the building systems, we have designed these members. But these portions we have required to performing the modeling for storage part, some water pressure, soil pressure we have considered. Okay, so when we using the cases, load cases, sorry, defined part or load patterns. Okay, so we have need to define the patterns, the soil pressure, water pressure, we have to be considered, or we have need to apply, see the deform shape, animation shape, the pressure will become applicable or not. Okay, so finally see the design part. In design part, we can see how much amount of movements will become acting. On the
yes.
behalf of movement, with the help of Excel sheets, we can identify, sir.
Mhm. Okay, fine. So this is all about our training program and the facility that we will provide with this training. Like we will provide you live class, okay, live class plus recording of the class plus special doubt session. Okay, these all are the requirement for the training. Okay, so thank you very much. Uh, have a nice day.